In this assessment, we're going to use the ratio of products obtained in the radical halogenation to tell us about the relative reactivity of a tertiary versus a primary CH. We expect the tertiary CH bond to be more reactive because the tertiary radical is more stable, and yet we end up with the tertiary as being the minor component of the mixture. Why that is? Because there's only one way to make the tertiary carbon-fluorine bond, whereas there are 9 ways to make the primary carbon-fluorine bond. That's going to be important when we set up our math. So the way we're going to do this, we're going to take this value of 0.14, derived from the 14% that gives us the tertiary, and we're going to let X equal the relative rate of the tertiary CH bond, and Y be the rate of breaking the primary CH bond. Now, because there are 9 different ways to break a primary CH bond, there are 9 primary CHs, we're going to use in our equation, we're going to use that modifier of 9. And so this ratio of 0.14 is going to be the total number of times that the tertiary CH bond is broken, divided by the possibility of breaking the tertiary and the possibility of breaking the primary. Recall again, there's one way to make tertiary. There's one way to make tertiary. There are 9 ways to make primary. This 0.14 is this value, making the tertiary, over the possibility of making everything. Now, because we know or expect that breaking the primary CH bond is going to be slower, we're going to say that Y is equal to 1. This is going to make our math a lot easier so that now we can just simply solve for X with 1 put in here. Let's rewrite the equation that way. So it will be 0.14 equals X over X plus 9 times 1. Straightforward math, that's 9. We can now rearrange the equation, multiplying what's on the bottom times 0.14. So 0.14 times X plus 9 will be equal to X. Do that math here, 0.14X plus 1.26 equals X. Subtract 0.14x from both sides, we get 0.86x is equal to 1.26. Divide both sides by 0.86, we get that x equals 1.47. What is that calculation telling us? It's telling us that the relative rate of breaking the tertiary CH bond is 1.47 to 1 for breaking the primary. And so the answer to our question is 1.47 to 1.